Hi guys, this is the video notes for solving systems of equations using elimination. So this is the third and final method. Our first method was graphing. Our second method was using substitution, and now we're going to be using elimination. So I like to compare elimination to how we used to add double, triple, quadruple digit numbers where we just add them vertically. So I put this example on the top right. We would add down. So 5 plus 1 is 6, 2 plus 4 is 6, 4 plus 3 is 7, and so that would be the sum. So we're essentially going to do that same method, but with a system of equations. So we can do this when both of the equations are in standard form. So that means both equations have the x term and the y term on that the left-hand side. So we can just add them if we see that we have a positive 1y and a negative 1y, because those are going to cancel out. So if we add vertically, again, reminder that the x has a 1 in front of it, we can add the coefficients, 1 plus 3 is 4, and keep the variable. Now when we add positive 1y and negative 1y, they actually cancel each other out. So let's keep going. Copy down the equal sign, and then 5 plus 7 is 12. This is an equation we can easily solve. It's one step. Get x by itself by dividing both sides by 4, and we get x equals 3. Now, if we remember what all of our answers looked like, we either got an ordered pair, no solution, or IMS. So we only found one variable. We need to find the other. So this is where our step is the same as substitution. Pick one of the original two equations. I'm going to pick the first one and plug it in. So if it's x plus y equals 5, I can replace the x with 3 because I already found that x was equal to 3 in the first step. So another one-step equation, subtract 3 from both sides, and we get a y value of 2. And that's it. Write it as an ordered pair, x comma y, and you're all set. Now, it's not always going to be this easy where we have a positive 1 and a negative 1, y or x term, so we'll see a couple more examples of how we can get around that. So if we look at our second example, the one on the left, notice that we don't have like a positive 1x and a negative 1x in this example. So what we need to do, again, if we were to add right away, nothing would cancel out. However, we can change one or both of the equations. So if I look at that first one, I realize they both have two x's. So if one of them was negative and I added, they would cancel out. So let's multiply the entire first equation by negative 1 and distribute to each term so that way we can get a negative 2x. So negative 1 times 2x times y and times 4 is going to give me negative 2x minus 1y equals negative 4. Now I can add, because I have a positive 2x and a negative 2x, that will now cancel out. So negative 3 plus negative 1 is negative 4, keep the y. Negative 4 plus negative 4 is negative 8. A one-step equation, divide both sides by negative 4, and we get a y value of 2. Just like the first example, this step will always be the same for both elimination and substitution. Pick one of the original equations and plug in the value you know. I like to pick the one with the smallest numbers, so I'm going to pick that first one. 2x plus y equals 4, but I now know that y is 2. This equation is two steps, but that's okay. Subtract 2 from both sides, and then divide both sides by 2 to get x alone, and it's positive 1. Write it as an ordered pair, and we're all done. All right, let's look at our third example. So the first example we could add right away. The second example, we just needed one of them to be negative. But if we look at this one, we've got a 2 and a 3, and we got a 2 and a negative 1. So we can't add right away because nothing's going to cancel out. But I do see that I have a positive 2 and a negative 1, but if I could get that negative 1 to be a negative 2y, then they would cancel out. So if I multiply that term by 2, I've got to multiply the whole equation by 2. All right, because the definition of the equation, we have to have balance. So if I change one thing by multiplying by 2, I have to multiply every item by 2. So let's rewrite that equation, 2 times 3x, 2 times negative y, and 2 times 5. I'm going to rewrite that first equation below, just so I don't get mixed up. Now I can add them because the negative 2y and the positive 2y are going to cancel. So 6 plus 2 is 8, keep the x. Our y terms cancel out, and 10 plus 6 is positive 16. Solve the equation by dividing both sides by 8. Now I'll take this and plug it in to one of the original two equations. So it's 2x plus 2y equals 6. But now I'm going to plug in 2 for x. So don't forget parentheses when we substitute if there's a coefficient. So we're solving the equation 4 plus 2y equals 6. Our y value is 1. So x comma y, 2 comma 1. All right, we have 2 more examples. So in the last couple, we saw just adding right away. We saw multiplying by -1. We saw multiplying by one number. So in example 4, if we look at our x's, I've got a 1 and I've got a 4. I got a 10 and I got a 5. I think the 1 and the 4 is going to be easily changed. Anytime you have a coefficient of 1 or -1, those ones are the easiest to change. So I can see if I have a 1x and I have a 4x below it, I just need to change that 1x to -4x so that they're opposites with the same number. So a -4 and a +4. So that means I would need to multiply the x term by -4. So I'm going to multiply the whole equation by -4 and distribute. All right, so now my x terms are going to cancel out. I'm just going to rewrite that just so it looks a little bit neater. My x's cancel out. My y's add to -35y, and my numbers on the right add to -7. Divide both sides by -35, and I know you guys are going to your calculator to get a decimal, but just reduce the fraction. It's 1/5. So now we take one of the original 2, I'm going to use the first one, and plug in 1/5 for y. It's going to end up being a nice number because 10 is divisible by 5. So it's really x plus 2 equals 3 once we multiply 10 times 1/5. Subtract 2 from both sides and we get an x value of 1. So it is totally fine to get a fraction as your answer. Now, if you want to use a decimal, that's okay, but if it's a decimal that doesn't end or doesn't terminate, you have to use the fraction. So if you always want to play it safe, keep it as a fully reduced fraction. Do not use a decimal because if we round, that's going to cause the other answer or the other variable to also be incorrect. All right, our last example is one where we are going to have to change both equations. So we have a 4, we have a 6, and we have a 5 and a -7. Now, I can't change 4 to get 6 or 6 to get 4, 5 to get 7, or 7 to get 5. So what we have to do is find their least common multiple. So think of the smallest number that both 4 and 6 can multiply into. So I noticed that 4 and 6 can both multiply to 12. That's the smallest number they both go into. And 5 and 7, the smallest number is 35. All right, but I like the idea of the opposite signs for the y, so let's go ahead and change the y. You can also use 12x and -12x if you wanted to still get the right answer. So I want that first equation to have a positive 35y and the second equation to have a negative 35y. So that means I'm going to multiply the first equation by 7 and the second equation by 5. Let's distribute. And then distribute the 5 into the second equation. So now I have a positive 35y and a negative 35y, which will cancel when I add. So 28 plus 30x, the 35y's cancel, and then 42 plus -100 is -58. So we're actually going to get a nice number for this one. Take one of the original equations, I'm going to pick the first, and replace x with -1. Multiply and then solve. So our final answer, -1, 2. So again, we saw an example of each different type where we have to change nothing, so just add right away, or we have to change one equation, or we have to change both equations. So there is no wrong answer if you want to eliminate x's or y's, as long as you end up with a positive and a negative of the same number for the same variable. Try these 2 U-tries on your own. Show all your work, and then you can meet with me over Zoom if you would like to check them. Thanks for listening.